Welcome to the Universe Unveiled, where we explore the deepest mysteries of the cosmos, from warp drives to the nature of consciousness. Humanity has always dreamed of breaking the ultimate speed limit, traveling faster than light to reach the distant stars and new worlds. Einstein's theory of relativity established that nothing can travel faster than light, setting a strict boundary for our exploration of the universe. However, modern theoretical physicists are now challenging this boundary, suggesting that we might be able to bend space itself to travel faster. In the 90s, physicist Miguel Alcubierre proposed a mathematical model that allows a spacecraft to ride inside a protective bubble of spacetime. This drive works by contracting space in front of the ship and expanding it behind, moving the bubble faster than light itself. The main problem with this theory was the requirement for vast amounts of negative energy, a form of exotic matter not yet found. Recently, researcher Eric Lentz proposed a new solution using conventional positive energy, bringing us one step closer to making this a reality. This breakthrough suggests that faster-than-light travel might be possible without breaking the laws of physics or requiring impossible exotic materials. Dr. Harold Sonny White, a former NASA physicist, has been leading experiments to detect actual warp fields on a microscopic scale today. While studying the Casimir effect, White and his team accidentally discovered a structure that matches the mathematical prediction of a warp bubble. This was not a theoretical simulation, but a real-world observation of a micro-warp bubble structure, a potential historic scientific breakthrough. If we can scale this technology up, humanity could reach the nearest star system, Alpha Centauri, in just weeks instead of millennia. While warp drive is the future, the current race for space dominance is happening right now within our own solar system's backyard. A new space race has begun, with nations competing to establish a permanent presence on the Moon and exploit its valuable resources. India recently made history with the Chandrayaan-3 mission, successfully landing a spacecraft on the treacherous and unexplored south pole of the Moon. This achievement made India the fourth country to land on the Moon, and the very first to reach the resource-rich southern polar region. The rover, named Pragyan, immediately began exploring the surface, analyzing the soil composition, and searching for definitive signs of frozen water ice. Water ice is the gold of the new space age, as it can be converted into oxygen for breathing and hydrogen for fuel. However, the mission faced a critical challenge as the lunar night approached, bringing temperatures down to -200 degrees Celsius. The rover was put into sleep mode, hoping it would wake up when the sun returned, but unfortunately it never signaled back home. Just days before India's success, Russia attempted to reclaim its space glory with the Luna 25 mission, aiming for the same landing zone. The mission was intended to demonstrate Russia's continued capability in space exploration, but things went wrong during the final orbital descent maneuver. An engine burn lasted longer than planned, causing the spacecraft to crash violently into the lunar surface, ending the mission in failure. This contrast between success and failure highlights the extreme difficulty of spaceflight and the rising prominence of new players like India. Beyond the political race, the Moon itself holds terrifying secrets that have puzzled scientists and astronauts for more than 50 years. During the Apollo missions, astronauts placed seismometers on the surface to record vibrations, leading to a discovery that shocked the scientific world. When NASA intentionally crashed spent rocket stages into the Moon, the seismic data showed the Moon ringing like a giant bell. Instead of the vibrations dying out quickly like on Earth, the Moon vibrated for hours, suggesting it might be hollow or rigid. This led to the controversial hollow moon hypothesis, suggesting vast empty spaces exist inside, possibly formed naturally or even artificially constructed. In the 70s, two Soviet scientists even proposed that the Moon could be an ancient artificial spaceship parked in orbit around Earth. While mainstream science rejects the spaceship theory, the density data confirms the Moon is much lighter than it should be for its size. The mysteries don't end with geology. Astronauts from both the US and the Soviet Union have reported encountering unexplained aerial phenomena. Declassified Soviet files reveal that cosmonauts on the Salyut space stations filmed strange objects that seemed to investigate their orbital outpost. These objects displayed flight characteristics that defied physics, moving instantly from a standstill to hypersonic speeds without any visible propulsion. But perhaps the most shocking evidence comes from the hellish surface of Venus, captured by the fearless Soviet Venera 13 lander. In the panoramic photos sent back, Russian scientist Leonid Ksanfomalidi identified an object that he claimed looked like a living scorpion. He analyzed multiple images and claimed the object appeared, changed its position, and then disappeared, suggesting biological activity in the extreme heat. Most scientists dismiss this as debris or lens cap artifacts, but the possibility of life adapting to such hellish conditions remains intriguing. Leaving the material universe, we turn to the mystery of consciousness. Dr. Robert Lanza proposes a theory called biocentrism, changing everything. Biocentrism argues that the universe does not create life, but rather, life and consciousness create the universe through the act of observation. This implies that without a conscious observer, the universe exists only as a probability wave, waiting to be collapsed into reality. If consciousness creates reality, then death might be an illusion. When the body dies, the information of consciousness may simply transition. Lanza suggests that consciousness is a form of energy that cannot be destroyed, potentially moving between different branches of the multiverse. Quantum physics supports the idea that information is never lost. Your memories and awareness are quantum information that persists forever in space-time. Finally, we look at the fabric of reality itself. Deep underground at CERN, scientists hunt for the God particle, the Higgs boson. The discovery of the Higgs boson confirmed how particles gain mass, acting as the invisible glue that holds the entire universe together. However, recent measurements suggest the Higgs field might be metastable, meaning the universe could theoretically collapse into a lower energy state. This vacuum decay would wipe out everything instantly, but scientists assure us this won't happen for billions of years, if ever. From the smallest particle to the vastness of space and the mystery of our own minds, the universe is stranger than fiction. We are just beginning to scratch the surface of these mysteries. Every answer we find leads to a dozen new questions. Thank you for joining us on this journey. Stay curious and subscribe to the Universe Unveiled for more explorations into the unknown. Until next time, keep looking up at the stars. The scientific community thrives on debate and skepticism, forcing us to constantly refine our understanding of the cosmos and our place within it. As our technology advances, the dreams of science fiction become the blueprints for our future engineering projects in the void of space. Colonizing other planets is no longer just a fantasy. It is becoming a necessary step for the long-term survival of humanity. Instruments like the James Webb Telescope allow us to peer back in time, witnessing the birth of the very first stars. Black holes remain the ultimate test for our physics, places where gravity is so strong that not even light can escape. Artificial intelligence is now helping astronomers analyze vast amounts of data, finding patterns that human eyes would miss entirely. We have discovered thousands of exoplanets, some of which might host conditions suitable for life forms completely different from us. Understanding the building blocks of life helps us search for biosignatures on other worlds, looking for the chemical fingerprints of existence. We continue to listen to the radio silence of the galaxy, hoping to catch a whisper from another intelligent civilization. Our silent ambassadors, like Voyager, carry messages of peace and music, drifting forever in the hope of being found one day. String theory suggests there are more dimensions than the three we see, curled up tightly in every point of space. We are all made of stardust. The heavy elements in our blood and bones were forged in the fiery deaths of stars. Our own star is a violent nuclear reactor that sustains us, but also poses a constant threat to our technological civilization. The aurora borealis is a beautiful visual reminder of the invisible magnetic shield that protects all life on Earth from radiation. Planetary defense is no longer a movie plot. We are actively testing ways to deflect asteroids that could threaten our planet. We have proven that we can alter the path of a celestial body, giving us a fighting chance against future impacts. Satellites also look back at Earth, providing crucial data on our changing climate and helping us manage our home planet better. However, our orbit is becoming crowded with space junk, creating a minefield that could trap us on Earth if not cleaned. Innovative solutions are being developed to capture and remove this debris, ensuring that the path to the stars remains open. Inspiring the next generation of scientists and explorers is essential to continue the legacy of discovery that we have started. Looking up at the night sky reminds us of our humble place in the universe and connects us to our ancestors. Mathematics is the universal language that allows us to communicate with the cosmos and decode the laws of nature. Deep underground, silent experiments wait for dark matter particles to interact, hoping to solve the mystery of the invisible universe. Dark matter makes up most of the universe's mass, yet we cannot see it or touch it. We only feel its gravity. Even more mysterious is dark energy, an unknown force that is tearing the universe apart at an ever-increasing rate. This acceleration points towards a lonely future where galaxies drift so far apart that the night sky becomes empty. But some theories suggest a cyclic model, where the end of one universe is simply the seed for the next one. Quantum computers may soon give us the processing power needed to simulate entire universes and solve these ultimate cosmological riddles. We are the universe's way of knowing itself, collecting information and stories to make sense of the chaos around us. As we merge with our technology, we may evolve into a species capable of surviving the death of our home star. Interstellar travel may require generations to complete, with people born and dying on ships without ever seeing a planet. Alternatively, hibernation technology could allow astronauts to sleep through the centuries, waking up fresh at a new destination. Asteroid mining could provide the unlimited resources needed to build these megastructures without depleting Earth's remaining natural reserves. A space elevator would revolutionize travel, making the trip to orbit as cheap and easy as a simple train ride. Terraforming Mars might begin with an artificial magnetic shield, allowing the planet to thicken its atmosphere and warm up. Bringing life to a dead world is the ultimate test of our mastery over biology and planetary engineering techniques. We are currently transitioning towards a Type 1 civilization, one that can harness all the energy available on its home planet. A Type 2 civilization would build a Dyson sphere around their star, giving them virtually infinite energy for any project. Wormholes could act as cosmic shortcuts, connecting distant points in space and time, allowing for instant travel across the universe. However, manipulating space-time brings the risk of time travel paradoxes, which could destabilize causality and reality as we know it. Some physicists argue that our entire three-dimensional reality is actually a hologram projected from a two-dimensional surface. The fine-tuning of the universe is suspicious. If gravity were slightly stronger or weaker, stars and life could not exist. The zoo hypothesis suggests that aliens are aware of us, but choose not to make contact, observing us like animals. Or perhaps there is a great filter, a catastrophic challenge that destroys all advanced civilizations before they can colonize space. We must ensure that our own technological adolescence, with nuclear weapons and climate change, does not become our great filter. The International Space Station proves that former enemies can work together for the advancement of science and peace. Europa, a moon of Jupiter, hides a massive global ocean beneath its ice, making it a prime candidate for alien life. Future missions will send submarines to melt through the ice and explore these dark alien oceans for the first time. Titan offers a bizarre mirror of Earth, with rivers and lakes, but made of liquid methane instead of water. Life elsewhere might not be carbon-based like us. Silicon-based life forms could exist in high-temperature environments. The famous WOW signal detected in the 70s remains the strongest candidate for a radio transmission from an alien civilization. Oumuamua, the first interstellar visitor, behaved strangely, leading some to speculate it was an alien probe rather than a comet. The Galileo project is now systematically searching for physical evidence of extraterrestrial technology near Earth to solve these mysteries. We are also rewriting the code of life itself, creating synthetic organisms that could help terraform planets or cure diseases. Bioprinting organs in zero gravity is a promising new field, utilizing the lack of gravity to build complex tissue structures. Space tourism is opening the final frontier to civilians, though currently it remains a luxury for the ultra-wealthy. Failure is a part of progress. Every exploded rocket teaches engineers valuable lessons that make the next vehicle safer. Mastering nuclear fusion would provide us with the same power source as the sun, solving our energy crisis forever. Nuclear propulsion is the key to fast travel within the solar system, reducing the trip to Mars to mere months. Light sails pushed by giant lasers could accelerate tiny probes to 20% the speed of light, reaching other stars. The psychological toll of deep space travel is immense, requiring astronauts to have minds as strong as their bodies. Virtual reality will play a crucial role in keeping space travelers sane, allowing them to visit Earth digitally. AI companions will also serve as friends and therapists, monitoring the crew's mental state and providing social interaction. Over generations, humans born in space or on Mars will physically evolve, becoming a distinct species from Earth humans. This divergence could lead to political tensions, as colonies eventually seek independence from the laws of Earth. We will need new laws and ethical frameworks to govern life in space, ensuring freedom and justice for all. The discovery of alien life would have profound impacts on human religion and philosophy, forcing us to rethink everything. Art and culture will follow us to the stars, as humans will always need to express their creativity and emotions. Imagine a concert hall on the moon, where low gravity allows for performances that are physically impossible on Earth. Zero-gravity sports will become a new form of entertainment, utilizing the unique physics of space for exciting competitions. We are creating backups of our civilization, storing data and DNA in secure locations off-world to prevent extinction. Space technology can also help us heal Earth, bringing clean energy and efficient resource management back to our home. Our curiosity is our greatest asset. It drives us to build bigger telescopes and travel faster to see what is out there. Neutrinos pass through us by the trillions every second, ghostly messengers from the sun that barely interact with matter. We can now hear the universe through gravitational waves, ripples in space-time caused by the most violent cosmic events. The cosmic microwave background radiation is the oldest light in the universe, a baby picture of the cosmos. Anomalies like the cold spot in this radiation map hint at the possibility of collisions with other parallel universes. Inflation theory explains why the universe is so uniform, suggesting it expanded faster than light in its first moments. Eternal inflation suggests that our universe is just one bubble in a vast foaming sea of an infinite multiverse. The anthropic principle states that we observe the universe the way it is, because if it were different, we wouldn't exist. Time itself is a flexible dimension, slowing down near massive objects, and possibly stopping entirely at the end of the universe. The laws of physics work the same forwards and backwards, yet we only experience time flowing in one direction. Entropy, the measure of disorder, dictates that everything eventually decays, giving the universe a definite direction towards death. Life is a rare anomaly that temporarily fights against entropy, creating complex order out of chaos using energy. Our ultimate destiny may be to transcend our biology entirely, becoming beings of pure energy or information. Whatever happens, our quest for knowledge is the most noble pursuit, defining who we are as a sentient species. It all starts with a simple question asked by a curious mind, looking up at the twinkling lights above. We stand on the shoulders of giants, adding our own small discoveries to the massive tower of human knowledge. Preserving this knowledge is crucial, ensuring that future generations can continue the journey where we left off. The unknown is not to be feared, but to be explored. It is the canvas upon which we paint our future. Every mystery we solve brings a little more light into the darkness, illuminating the grand design of reality. We are not separate from the universe, we are a part of it, the universe experiencing itself through us. Your curiosity fuels this channel. Without your desire to learn, these videos would have no purpose or meaning. What do you think is the greatest mystery left to solve? Let us know your thoughts in the comments below. If you enjoyed this deep dive, please hit the like button and share this video with fellow space enthusiasts. This has been a production of the Universe Unveiled. We are dedicated to bringing you the best science content. Click on one of these videos to continue your journey through the cosmos. Until next time, keep looking up.